Hello, I'm Baptista with Continuous Testing Academy. In this set of video courses, we provide continuous testing tutorials to bring you DevOps success using the right people, the right process, and the right technology. In this course, we're going to be talking to you about virtualized environments using service virtualization. This is one of the 11 disciplines of continuous testing that you've seen before. We're going to be focusing specifically on virtualized environments. Testing is still a barrier to speed. DevOps adoption is very high, but users still hit this QA wall. In a recent survey, 54% of adopters still experience a software testing bottleneck. And what does that really mean? But QA is still that bottleneck in DevOps shops. In that same survey, 63% of the respondents say that QA and testing is the bottleneck to their DevOps process. What's holding up continuous testing? It's what we call constraints and bottlenecks are all across the software development lifecycle. Those could be system constraints, they could be data constraints, or even cost constraints. And ultimately, things that constrain our ability to develop in parallel are also considered holds on this continuous testing journey. In a recent Vogue survey, over 80% of teams experienced delays in development and QA due to unavailable dependencies or systems. 56% of critical dependencies are unavailable when dev and test teams need them. 79% of teams face prohibitive restrictions, time limits, or access fees on needed third-party system and resources. So how can we overcome that continuous testing? Really, the proposition here is to explain what service virtualization really is and how we enable virtualized environments and ultimately continuous testing. Well, in this example right now, we have the front-end systems, which could be any device or object in the Internet of Things. It could be mobile applications, or even SaaS or cloud instances, or even partner ecosystems and partner development infrastructure, or external developers that you're hiring to work on your applications. On the other side of the equation, you have what we call the back end, which could be a secure environment. It could be a myriad of applications, or it could be an ERP or SAP instance. And even a mainframe could also be considered part of that backend. And third-party access or APIs could also be part of that backend system. And you'd have a middle layer. It could be the old ESB, or it could ultimately be an API gateway, for instance, in more modern terms. So this is the typical architecture that you see on these environments. So what happens if one of those back-end systems isn't available? For instance, if the third-party system is down for maintenance, do you have to sit back and wait? Typically you do. So essentially with service virtualization now, you can emulate those back-end systems at any point in time. So essentially what you're doing is you're isolating the systems and allowing you to continue doing your work when you need them, where you need them all the time. So ultimately it provides the tools to your development and your testing teams all the resources that they need when they need them. One of the benefits you see in using service virtualization to enable your virtualized environments and continuous test is in integration testing. What happens when you are able to remove constraints and by using virtual services instead of the real thing, you are able to expedite your development and testing process. You avoid manual, repetitive development mistakes, or the old traditional mocks and stubs are no longer needed. You are able to simulate web services, you are able to simulate middleware, you are able to simulate and replace third-party systems, APIs, or even the mainframe. Another benefit you see in performance testing is the ability to provide component-level testing. What does that mean? It means that you're able to test the component level performance that replicates and mimics the behavior of that component in production. You're truly able to isolate that component from other systems and truly test that component, that system under test. You're able also to insert negative conditions. What happens if a system is late to respond? How will your system under test respond? If you're able to enter error conditions of transposition of elements in a data set. What does that really mean to you is you're able to shift left the performance testing. You're able to test that performance behavior in the component while you're working on it, isolating yourself from other performance impacts, truly knowing what the performance behavior of your system under test is going to be. So one of the benefits we see also is a faster time to market. By having always available systems, all available resources all the time, our development and testing teams can continue work whenever they need. So they're ultimately able to test and work continuously. So there's no more waiting for back-end systems, for third parties resources to be available, access to be provided. No, you will have everything you need when you need them, where you need them. Also, you're able to speed up the development process by up to 50% sometimes. These are some examples of customers that have used service virtualization. Another thing we are able to provide you is not only the faster time to market, but in conjunction with the better quality. You're able to test sooner while you're working on the component, so there's no wait time for components to build together. You're able to test more often. You're able to increase the test coverage and also bringing negative testing capabilities which couldn't be worked otherwise. What would you do? Have wait for a mainframe or ask a mainframe to, hey, could you slow down your MIPS a little bit to see how my system performs? That's unreal. You're not able to do that. But you are able to use virtual services in the service virtualization model in order to slow them down or speed them up as needed. And the other thing, in terms of ultimate measurable value you see from the better quality, we are able to see some of our customers find up to 90% more defects at least one stage earlier in the software development lifecycle. And why is that? It's because they have all the resources when they need it, where they need it. Okay, who really benefits from service virtualization? These are just 3 examples of people that could use service virtualization. We could see where developers use it, enabling them to work in parallel. So instead of waiting for your team's component to be ready so that your component can be worked on, you can virtualize that away and use it while you're waiting for the additional component to come by. When the real thing comes in, you swap out the virtual version for the real thing and off you go. You continue your working. You're eliminating mocking and stubbing, which is very rudimentary, very focused on the unit test. The virtual service can carry on beyond the unit test. It goes into integration testing. It goes into performance testing. It's much more malleable, and you can share those resources, something you can't do with the traditional mocks and stubs. You are able to reproduce production defects or behaviors, allowing you to truly test and develop to what is real. You're also minimizing system availability or wait time because you have all the virtual resources you need when you need them, where you need them. For integration testers, for instance, you eliminate that wait time or the test data setup. All that time that is wasted setting up the test data or waiting for available systems, you don't need them anymore. You virtualize the environment, the test environment, and you're able to virtualize an API. You're able to virtualize what you're trying to integrate yourself to, and ultimately allowing you to work more continuously. You're able to have negative test coverage, which is something that you can't find any other way. You're able to provide your teams stable test environments that are virtualized, always available when needed. For performance behavior, like we talked before, you're actually able to reduce the infrastructure costs because you don't need to have a full-blown performance lab that will behave just like the real thing because you have the virtual services in the service virtualization model that allow you to have those responses and behaviors that you're trying to replicate in the performance environment. You're able to eliminate the wait for environmental sharing because you have individual users that have access to virtual services at their leisure whenever needed. You're also able to reduce transaction costs. For example, for a credit bureau access from a bank, instead of having to access the credit bureau, they can use the virtual services instead. Instead of paying a fraction of a cent to each of their credit bureaus, they can use that deferred cost investment. And here are 7 common service virtualization use cases we see from our customers. 1, there's a training environment where we're actually replicating and simulating the entire back-end system without need for maintenance of systems. The training environment is able to truly expand their coverage and replicate performance behavior without having to manage and maintain mock backend systems. It's truly a virtual service environment. Business in a box is ideal for use in integration testing. You can actually replicate your complete backend system and use that as your mock or virtual backend system. And once your acquiring organizations can integrate into that mock, that virtual version of your backend system, they're truly able to integrate to the real thing just as easy. Third-party APIs. If that third-party API isn't really accessible and ready to go, you can actually create a virtual version and work up against that virtual version or that virtual service. And once the real API is available, you can then switch it back to the real thing. Mainframe constraints. Is the mainframe only available to you at 2 a.m. on a Friday? That's the only time you can use the tool and have to wait the window if you can't make that deadline? Well, not anymore. We actually can virtualize the behavior of the mainframe, either externally, completely isolating you from the mainframe, or internally, inside the mainframe using CIC and connections. So the next example for the use cases we have is negative scenarios. You can use service virtualization to enable your developers and testers to replicate negative scenarios they've seen in the past and are able to use it in your future testing and development. The next use case we have is performance constraints. You're able to really stress test the application backends and the components using these virtual services. The time constraint. If you hit that project wall that must be overcome, your deadline is not going to move, but you have to be able to test, yet you're slipping on the testing time frame you have, well, use service virtualization. Because you remove yourself from other constraints, other dependencies, you're really able to use service virtualization as a way to shift left your software development lifecycle, where customers have actually shown 25 to 50% faster delivery to market by using service virtualization wherever they need constraints. So you're able to develop in parallel, you're able to develop faster and better software consequently. Here are 3 key takeaways we want to leave you with. 1, you find your toughest constraint and overcome it. Start somewhere. You can use one of the 7 examples that we discussed, and then expand as you learn. You can make it better, cheaper, and faster. You can make it better by testing more often using virtual services. You can make it cheaper by not having to invest in third-party systems and access fees, or you can do it faster by allowing you to test sooner or cutting out your test wait times. Thank you very much. My name is Baptista with Continuous Testing Academy.